recording this meeting. All right, so our task here is to take a look at correlation. And so correlation is the relationship between two variables, and the range of the correlation can go from -1 to +1. Okay, and so if it's on the negative side, it's a negative correlation. It's on the positive side, it's a positive correlation. And so this is used whenever we have two variables that are measured approximately continuously. Okay, so anything that is asking how much do you agree with something, scale 1 to 5, how much or how often have you done something, anything like that, any two variables that are like that, you can correlate. Correlations cannot be used when you're looking at nominal variables like marital status, race, gender, anything where the number assigned to the value is completely arbitrary. Correlations don't work for that. So correlations, though, are extremely useful, though, for most all other variables. So ordinal, interval, and ratio. You can use correlations for, and those are preferred usually over looking at like a chi-square table that will show you if there's any differences in the distribution not expected at random, but correlations really are the preferred measure if you can do it. That is, if you're not working with any nominal variables. Okay, so those are the basic parameters, right, for using correlation. When we want to take a look at a correlation in SPSS, let's take a look at first. Let's do something here. Let's create a violence index out of these items H1 FV1 through H1 FV8. This will be good practice at making what's called an index that we can use later for this class. And so we're going to make a violence index. This is just all items indicating some exposure to violence. So let's just take a look at these real quick in variable view. So I'm going to start off by making an index measuring exposure to violence. And I'm going to do Control F search, and I'm going to look for H1 FV1, H1 FV1, and I'm going to go to this column of variables right here, H1 FV1 through 8. And so seeing violence, having violence happen to you, seeing it again, witnessing it, got into a physical fight, you were jumped, you pulled a knife on somebody, you shot somebody. So all these, some of these are victimization, some of these are perpetration, but they're all exposure to violence. And this is how they are all measured. They're all measured 1, 2, 1, 0, or 0, 1, 2. Never once, more than once. Okay, so they're all measured in the same way. They're all measured in the same way. So that's an important thing just to keep in mind. In a moment here when we get into constructing indexes and scales. So part of this class we're going to talk about is combining variables together into scales and indexes. That's what chapter 6 in Babbie is all about. And this is a very common practice in the social sciences because any one measure, there's a lot of error involved. And so usually we want to get an overall assessment of something, especially when it's self-report, to avoid the error associated with any one item, and also to give the broadest possibility for people to say yes to the thing that we're interested in. In this case is violence. And so we though want to have measures of violence that are measured quantitatively in the same way. That is, if we're going to lump them all together into one index or one scale. And so so for these, we can go ahead and just let's do this. Let's just go highlight right over here, 1 through 8, and we're going to copy. And to make a variable, recall, we go into where it says transform and compute variable. Now, the target variable, it's called that, but it really is just you need to make up a name for this variable. So let's just call it violence index, all one word, can't have any spaces, violence index. And we're going to set that equal to the sum of all these violence items. Okay, I paste that right in there. And then we want to put a parentheses around this. And this is the way we do this, put a parentheses around here, type the word sum in front of it. And that's just, there's a bunch of shorthand over here for our arithmetic calculations, but I know sum is one of them. And parentheses after that. And then, oh, we have to put a comma after each one except for the last one. Okay, pretty sure, yeah, except for the last one. Okay, so a comma after every one, except for the last one. So you're summing those. So it's H1 FV 1 through 7, comma after each one, and except for the last one, and then close with parentheses. Okay. Are we all good? Yeah. Okay. Then go ahead and hit OK. Okay. Let me get to this other screen. So I think it probably is not sharing people at home. Okay. So people home should be able to see my output window now. It's showing this making violence index. Let's go ahead and run a frequency table on this to make sure that it came out the way we think it should come out. So you want to go to Analyze Descriptives. Always run frequency tables when you're making new variables, and sometimes before you're even running variables. So the last variable we made will be the last one on the list if we leave it sorted by file order. And we're just bringing it all the way down. We can put that over there. And if we want descriptive statistics for it, remember we go over here where it says statistics and we say, okay, let's give us the mean, the median, the mode, the standard deviation, and the minimum maximum range for this variable. Okay, so that's how we want to do that. You do that almost every time. That should be sort of something you do reflexively when you make a variable that's continuous like this, that's not like marital status, it's not nominal. You must always usually want the mean, the median, the mode, and all that, and the standard deviation. Okay, so we're gonna look at this. Okay, so this is a very right skew distribution. You know, most people are saying no to all of these items, and then you've got diminishingly small number of people out here on the tail that are involved in violence, either being a victim or perpetrator quite frequently. So that is our violence index. Okay, so let's take a look at something we've done before. Let's create a delinquency. We'll call it a delinquency scale here in a second. But let's go ahead and construct a delinquency measure, and then we're going to see how the index, violence index, and the delinquency measure correlate with one another. Okay, so let's go back. Let's go to see, stop sharing. Let's go to over here. I'm going to just select the delinquency items, and those are Control F H1 DS1, and it's H1 DS1 through 15. So we've done this before, but this is H1 DS1 through 15 is what we want. So I'm copying that. Now note here for the delinquency items, very important here that these are all measured the same way. We're not going to go through and check each one, but we know we've already done this. Each one is measured like this: 0, 1, 2, and 3. Okay, so again, before we start putting together items to create indexes or scales, it is very important to make sure that each item is measured in the same way. If it's measured differently, then we can do something about that, but it is really quite easy, especially for you all, to be keeping that in mind as the thing that you want to do when you're trying to create an index or a scale. Is look for items that are all measuring about the same kind of thing, are related to something, and also are quantitatively actually being measured in the same way. It'll make your life a lot easier. Okay, so we're taking those, and we're going to go transform compute variable. And let's go ahead and reset this so it'll get rid of that. We're going to go ahead and call this delinquency. And we'll go ahead and set that equal to, okay, it's going to be, just the sum of all these items. So again, we'll just parentheses sum. And we're going to put a comma, comma, comma after all of these, except for the last one. Actually, I don't know if it gets fussy if you put a comma after the last one or not. I just think just syntactically, like with other programs, you don't want to do that. But okay, and so that's then yeah, close it out with parentheses at the end. And yeah, this is we can go ahead and just sum this up. Whenever the items are all measured the same way, you can always sum or take an average. We could have summed or taken an average. It doesn't really mathematically matter that much, and so we're going to do that. Okay, and let me go back to my other screen here so people at home can make sure and see it. Okay, so showing our syntax, so we did this. It's always good to check this, folks, when you're making new variables to make sure you did what you thought you just did. And it's just showing you, yeah, this is what you told me to do. Okay, so let's go ahead and run our frequency table on that. So people just get in the habit of doing this, descriptive statistics, frequencies. And then we can put violence index back, and then we can go get delinquency and put that over there. Okay, and let's go ahead. We don't need to mess with statistics again. We're already going to get the stuff we already need, and this makes sense to ask for these stats for delinquency too, because it's approximately continuous variable. It's higher levels mean more and more delinquency. So go ahead and hit. So we've got a variable that ranges from 0 to 45. And here are all your stats for that. Okay, so you have these two items. Now you got delinquency and violence. Okay, how are these two things related? Well, we can probably suppose that delinquency, while it's not all violence itself, is positively correlated with items that specifically reference violence. Because people who are risky in one domain tend to be also risky in another domain, and we can go on and theorize until the cows come home as to why that might be. But I'm going to say, yeah, I would put money on the fact that these two items, violence and delinquency, are going to be positively correlated. So correlations can be positive or they can be negative. Or they can be exactly 0, but usually it's going to show a positive sign if it's just a hair above 0. If it's exactly 0, then it means there's no relationship. If positive, it means when one goes up, so does the other. And so that's what I'm hypothesizing about the relationship between delinquency and violence here. And so when we want to do this in AdHealth, what we want to do, we want to go in to where it says analyze and go to where it says correlate. Now there are several entries for correlate, but the one you want to go to is bivariate because it's looking at a relationship between two variables. So for bivariate, okay. And what we want to do here is by default, it'll have this Pearson correlation checked and a two-tailed significance test. So it's going to give you the Pearson R. The statistical letter for the correlation is R, and the two-tailed test is what we're asking for, and it's saying it's going to go ahead and give you an asterisk when it's significant, but I think it shows you the p-values anyway right below them. And we don't need to do anything else here. We'll go ahead and hit. Actually, we're going to go get our variables. So let's go here and collect violence. We want delinquency. Okay, and let's go ahead and hit OK. So we're looking at a correlation between those two items. Okay. So what you see here is what's called a correlation matrix. And so all variables in this are a matrix. You can make this matrix have 30 variables in it, and it would be a very big table, but it's still considered a correlation of bivariate correlations, or a matrix of bivariate correlations, because each time it's just looking at the relationship between one variable and another variable. But you could have put in a lot more things in there, like frequency of drinking, frequency of prayer, frequency of, you name it. You could have put it in there and see what the correlation was. But what we're doing right now, let's just focus on what is showing here. This is can people at home see this correlation box? Somebody give me a thumbs up or something. Okay, great. I see some thumbs going up. Wonderful. Okay, so this is a correlation matrix. And what you're looking at here is the relationship between violence index and delinquency. So at this intersection right here, you're looking at the Pearson R correlation, or the value of R is 0.562. And it is statistically significant. We know this because it's starred with an asterisk, like they said they would, but also here is the significance level of the p-value. It is statistically significant. The threshold for this is 0.05, like any significance test at two tails, and so it's a statistically significant correlation. Correlations, recall, can range from -1 to +1. So this is in the positive range. This is saying basically that as violence goes up, so does delinquency, and vice versa. You could also say it the other way around. We don't know the directionality of this at all. All we know is the two are associated. So because this is in the positive range, and it's about halfway between 0 and 1, this is a modest to strong correlation. So this is a pretty hefty correlation here, and we can easily understand why this would be the case. Some of the delinquency items do, I think one of them does reference violence, but not the exact same kind of violence. So maybe not completely endogenous one another, but there's significant overlap here in the way that these two things are related. So this is a positive correlation. Correlations on the positive side can be as strong as 1. Or be as small as 0.01. So if you have a correlation in the range of 0.01 to 0.1, that's like a weak correlation. A 0.1 to somewhere between a 0.3 is somewhere between a modest, like a modest correlation. In the social sciences, really anything above a 0.3 is considered a strong correlation. And the same way on the negative side, if you have like a negative 0.1 correlation, that's considered kind of a weak negative correlation. If you have a negative 0.3, that's a modest negative correlation. And if you have anything above a negative 0.3, usually in the social sciences, that's considered a pretty strong correlation. So, you know, by those standards, we've got a pretty strong correlation here. The number right below there, 6,455, that's the number of people that completed or gave valid responses to the violence index and the delinquency score, or the delinquency items. So that's the number of non-missing cases, 6,554. And now notice there is a diagonal of ones running down this matrix. There always will be that. What is below that diagonal of ones is the same information repeated. It's just showing you this time the correlation between delinquency and violence. So it's the same thing, 0.562. So you're always going to see that in a correlation matrix below the diagonal of ones. Now, the reason why there's a diagonal of ones is because it's showing you the correlation between this measure and itself. See, correlation between violence index and violence index is 1. The correlation between delinquency and delinquency is 1. That's just, they always print that in correlation matrices, but that's just how naturally it would be. It would have to be 1. So that is looking at what a correlation matrix looks like in SPSS, and generally how they're printed out in most other statistical packages. And the key elements here are the correlation coefficient R. In here, it's positive 0.562, and so that's a modest, if not strong, positive correlation between violence and delinquency. It's statistically significant. The p-value is less than 0.05. And we could describe this in layman's terms as kids who are violent also tend to participate in other forms of delinquency. And you could say that's true for more than half of the population, because the correlation is 0.562. Now, you don't really necessarily you don't really want to interpret correlations like that as a percent of how many cases is it true for, but it gives you a sense of the strength of the correlation. If the correlation were 1, it'd be like it's absolutely true for 100% of the population that as violence rises, so does other forms of delinquency. Now, there's a lot of deviations around that trend. So that's why it's not a correlation of 1, it's only a correlation of 0.56. Anyway, that is a correlation matrix involving two variables that we constructed. Now, a question that often comes up is that when we are putting together items from several variables to construct something like a delinquency scale, do we have a good justification for doing that? And that is usually answered by assessing the reliability of the scale itself. And so this is done through lots of different ways. One of the ways that I'm going to show you here of assessing the reliability of the scale is looking at how items in the scale correlate with one another. And after one looks at that, then you can assess whether or not it would make sense to combine these items into one scale rather than looking at a bunch of items separately, because it's worthwhile to do that. So what we're going to do here is we're going to take a look at all of the items that make up the delinquency scale. Okay, so those items H1DS 1 through 15. We are going to do that up here where it says analyze, and where it says scale. Okay. So we go down to where it says scale, and over here it says reliability analysis. Okay. And so we want to go into this window here. And what we want to do is we want to put all of the items in the delinquency scale over here. I think we're just going to have to put those over there because it's not letting me right click on there. So what we want to do is go ahead and display variable names, sort alphabetically, and we want to have the items in our scale over here, the H1DS 1 through 15. And so, oops, I went the wrong way. H1 1 through 15. Okay, for some reason, these are slightly out of order, but you just want to get all 15 of them over there. Okay, so, all right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Did I get 15? I got it. 1, 2. Okay. So yeah, so make sure you have all 15 of those over there. And we can go over here to where it says, sorry, when you go over here, you want to click where it says statistics. And over here where it says enter item, go ahead and hit correlations. We are going to look at the correlations involved in the and all these items in the delinquency scale. Right here it says model, it says alpha. So the type of reliability analysis that we are going to assess is called Cronbach alpha. And so that is a very efficient way of assessing how reliable a scale is. That is, how well do all these items hang together in a correlation such that they would constitute a scale. All right, so we go ahead and hit OK on this. So what we get is here is this printout, and so people at home should see where it says reliability, scale. Okay, and this is giving you the percentage of cases that were included that didn't have missing cases, or the missing values on the items. So it got rid of 1.6% of them, which is okay. So we have down here now a printout where it says reliability statistics. Okay. Now, we didn't standardize our items. So what we want to do is look at where it says Cronbach's alpha over here. There's two places where it says Cronbach alpha. We didn't go through a standardization process, although they're all measured the same way. So I wonder, this one may be just as good. But what we're looking at here is this Cronbach's alpha score. So go with this first one here. That this is showing you to the degree to which all of these correlations are reliable indicators. That these items together are a reliable indicator of some underlying measure that we're trying to get at, and we could call that delinquency in this case, because all of these things, by definition, by legal definition, are measuring things that if an adult were to do them, they would be illegal. So we are, by definition, measuring delinquency, but these items really are measuring behaviors that are quite different from one another. Consider selling drugs and burglarizing, or consider using graffiti to paint a wall and getting into a group fight. Now, these things are different behaviors. So the question is, are they really all indicative of the same sort of underlying thing that we're trying to measure? Let's call that delinquency. Certainly fits the legal definition of it. The Cronbach's alpha score is saying, yes, it is. Now, Cronbach's alpha is considered like a correlation among positive correlations. And so when you have a good scale, your Cronbach's alpha should really be no smaller, no smaller than about 0.6, and should range from about 0.6 to about a 0.9 something. And so you're looking for a Cronbach's alpha between like a 0.6 to about a 0.9. And within that range somewhere, that is telling you that all of your items hang together well enough that they constitute one scale. And you can go ahead and combine all these items together into one scale, measuring something like whatever theme they are being related to. So in this case, it is delinquency. You might have a scale measuring attachment to parents, religiosity, health, a number of different things that all are asking about some common theme. And you can assess then how well they are doing that by looking at reliability analysis. So one way that you can know whether or not you're probably going to have a scale where all the items are hanging together is by looking at all the correlations. So what you're looking at here, all the items down here, these are all correlation coefficients. So here, this is the correlation 0.197. This is the correlation between burglary and using spray paint. So yeah, there is a positive correlation between burglary and spray painting, meaning that the people who burglarize, at least some of them are also the people who spray paint. Spray paint graffiti. So there is a correlation. It's not a strong correlation. It's it's only 0.197, but it's a positive correlation nonetheless. Okay. Again, we have this big diagonal of ones running down the correlation matrix. This is just telling you that this is the correlation between the same items. And so you're always going to see a 1 there. And so there's some of this information is repeated on both sides of the correlation matrix. So you might want to look at one above or below the matrix. But here's another correlation between, let's say, selling drugs and burglary. That is a 0.270. Okay, so again, it's showing a positive correlation, and that's telling us that the risk of being involved in drug sales goes up with burglary, because the two are correlated. And so the kids, some proportion of the kids who are involved in burglary are also involved in illegal drug sales. So you could say, well, that's true for what, like 27% of the population, maybe, but again, that's kind of a sketchy way to interpret a correlation. Generally, you just want to say that there's probably maybe about at best a modest correlation between burglary and drug sales in the ad health data, and so we can then extrapolate to the general population and say that's probably true of the general population as well. But again, what you're looking at here is all the correlations for the delinquency items. And what you notice here is that all of these items, without exception, they're all positively correlated with one another. Okay, in order to make a scale and for it to show reliability in acceptable range between 0.6 and 0.9, all of the items in your correlation must be positively correlated. All the items in the correlation matrix must be positively correlated. They all must be, because if they're not, then it's not going to produce a Cronbach's alpha score in the range that's acceptable. And so that goes back to why it is very necessary to check out how your items are measured in the first place before you start combining them into a scale. Okay. And so that's one example of a scale. Now, I have a couple other examples here of how we can produce a scale measuring some other underlying variable that we think all these items are indicators of. And so there is a parental attachment scale that one could create. If we take a look at some of these items that look at the degree of attachment between the child respondent and his or her mother is usually what these things are referencing. Okay, so if we go to our variable view and we take a look at H1WP, Control F, H1WP, H1WP9. Okay, you folks down here. Okay, and so this is an item that asks, how close do you feel to mom? And this next item down, H1WP10, how much does, I think, she care about you? Okay, so both of these items are assessing the degree of, I would say, emotional attachment between teen participant or the student age respondent and their degree of attachment to their mother. These are very common type of attachment items that appear in a lot of general social science surveys and psych surveys. The way this thing is measured, 1 to 5. Okay, so the higher the score, the more you feel attached to mom. All right, and so they're both scored like that. So these two items, the way that they're scored, they both look like they're measuring the same thing. They could be combined together into a scale. However, we might think, well, a two-item scale, that's kind of a little pathetic. We want more items in there. Usually, when you're trying to get at some underlying thing like attachment, you are wanting to have lots of items. This is what separates indexes from scales. Okay, an index is measuring something that unequivocally is accounting for something that there's no really debate over what you're measuring. So when we looked at a violence index, we are definitely measuring violence because the behaviors all referring to physical violence. Delinquency, no doubt, is measuring illegal behavior by definition. However, the behaviors themselves were so diverse, one can make the argument that really you're measuring different things. However, the scale, the Cronbach alpha told us that all of these things are nevertheless hanging together statistically because they're all positively correlated. Okay, so that's a statistical argument for a scale. Now, when you get into issues like attachment, depression, some of these squishier sort of social psychological variables, even more so, you need to have multiple items and check the reliability analysis because it's not completely evident that they're all measuring the same thing. You can look at the language of the question. You're all human beings and sort of relate to how a kid would respond to this, what's going on in their head, and think about, okay, are all these items probably measuring the same underlying thing given the language and how I would probably respond? For these two items, you could probably say, yeah, that is certainly the case. Okay, so we want to have one more item in here, and we're going to do this for purposes of just showing you how you sometimes you have to recode things to make them all work together in a scale. So H1PF1. So let's look at H1PF1, H1PF1. Okay, and so H1PF1, mom is warm and loving. All right, so the language certainly matches with the first two items. However, let's look to see how this is measured. DRAT. It is also a 5-point scale, but it's in the reverse order. Okay, so this is the case where you probably want to reverse recode this item so that then you can combine it with the other two items and make an attachment scale. You could not do this with the item the way it's measured now because it's going to be negatively correlated with those other items. You want to reverse code it so it will be positively correlated. So let's look at the correlation matrix before we reverse code this item. Let's correlate this item with the other two. And I'm just going to show you how this works out and why you need to do this if you want to combine this together into these three items into one scale and call it something like parental attachment. Okay, so if we go to analyze and we go into correlate and we go over to where it says bivariate, let's go ahead and reset this. And let's go ahead and display variable names, and then let's sort alphabetically. H1 WP9 and 10. H1 WP9 and 10 is the first two I'm grabbing because those are just the two that I just remembered. H1 WP9 and 10. There's 10. There's 9. And here's 9. Okay, 10 was separated from 9. HPW, okay, so 9 and 10, and then we want H1RE, I'm sorry, we want H1 PF1. So up here, H1 PF1. There it is. Okay, so H1WP10, H1WP9, H1PF1. So those are the same three parental attachment height items. H1PF1 was kind of the odd guy out because it was scored in a way that higher scores equal a more cold and brittle relationship with mom, apparently, because it's more you disagree with that, right? So let's. So you're strong. The higher the score, the more you're strongly disagreeing that mom is warm and loving. So yeah, I would say that's gauging cold and brittleness of the relationship. All right, so we go ahead and hit OK, and let me stop sharing this real quick and go back to my other screen. Stop. Oops. Okay, right. And so here is the correlation between how much does she care about me and you feel close to mom. A strong positive correlation, as we would suspect. Okay. And then we have a correlation over here that's negative with warm and loving. Well, the reason that it's negative is because of the fact that it's reverse coded. And so if we recode that so it is not negative, then what we'll get is a positive correlation in the, it'll be the same number, it just won't be negative anymore, okay? And the same goes for this item here. So, so let's take a look back at those items themselves. Okay. And let's go to the, so this is the one we want to recode, right? So this is the one that needs to be recoded so that all of these are in the reverse order than from what they were before. And so let me just check something real quick here. Oops. And let me recheck this real quick. Okay. 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 So what we want to do then is recode this H1 PF1. So we want to go to transform, recode in a different variable, and go to display of variable names, sort alphabetically. And we're looking for H1PF1. And we'll just call this reverse H1PF1 change. Okay, so to reverse code the thing, we just need to flip it around so all the values are flipped in the coding. So if you had a 1, now you're going to have a 5. If you had a 2, now you're going to have a 4. Because 3 is the right in the middle. There's no place for it to switch with in the rank ordering of it. So 3 stays 3. 4 then goes to 2. And 5 goes to 1. And then the missings, we can keep those missing. So system or user missing, we will keep those missing. Okay. Right. Make sure and hit add to get that over there. Yeah, I about forgot to do it. Okay, so yeah, that's a reverse coding situation, and there, depending on the number of levels you have to a variable, it'll be different. But that's just reverse coding, so we can get the things. So it's going to be rank ordered in the way that a higher score equals more attachment felt to mom. All right, we hit OK. All right, let me go back to my other screen. Oops. Let me. What am I doing here? Okay, here we go. All right, and so what we can do to make sure we did this correctly, let's go ahead and run frequencies on this. Yeah, I know this is, get very used to doing this. So we want to get our reverse coded one in there. All right. And then let's go ahead and sort this by variable names and then alphabetical order and find the original H1 PF1. Oops, I keep missing it. Okay, H1PF1. Okay. And we go ahead and just run this, and we want to make sure that things have been flipped. Okay, so here's the original one where the people who disagree are at the very top of the scale. Now they're at the bottom of the scale, and it seems that everybody has threes still in the middle. Disagree or agree, they're still in the middle, right? And so everybody has flipped places. So good. So we have reverse coded this thing so that everybody has flipped places. Okay, I wonder why that. Okay, right. Okay, so now we are in the position to, let's re-examine the correlation matrix. We should see then the same thing, but no negatives. No negative. Negatives should be gone. So let's go ahead and take a look at the correlation matrix again, but we're going to use our reverse coded item. Get rid of this one. So this is the original one. This is the one we just worked on to reverse code it. So let's get rid of it. And let's go down. Actually, if we sort by file order, if you do that, right click, sort by file, it'll be the last one we made. There we go. And put that one instead. So, we're putting that one in there because that's our reverse coded one. So now, because they're all going in the same direction, they should all show positive correlations now. Okay. Yes. All right. So, all right. So what we're seeing now is a positive correlation between all of these items that theoretically should be tapping into an underlying dimension or scale that we want to call parental attachment. The correlations range from a high of 0.523 to a low of 0.391. So all of them are in the modest to strong range especially when it comes to social science data. And so all three of these items, at least based on the correlation matrix, are all hanging together. They're all positively correlated. Let's go ahead and see, okay, well, are they, though, good enough to make a scale out of? So we have to go into where it says analyze, and we want to go into where it says scale, and go to where it says reliability analysis, and go ahead and hit reset. And we want to put over there our reverse coded item, and then the other two items that were not reverse coded. So I'm going to go display variable names, and I'm going to go sort alphabetically, and I'm going to want H1, WP 9 and 10 over there. Let's skip it. H1, WP 9. And it does not matter at all what order you put these things over there. Okay, so now we have that over there, and let's see. Let's go ahead and look at the inner item correlations again. And there's other stuff that you can ask for in here, but this is good enough. So we just want the inner item correlation so we can see the correlation matrix. Although we already just saw it. But okay, so did I click that? Where's my correlation matrix? Let me do that again. Just a second. Let me get back to. Maybe I didn't click it. Yeah, I didn't do it. Okay, there. Clicking that. Okay. All right. So people at home, can you see this where it says reliability statistics? Yeah, okay. So what we're looking at then is the reliability of the so-called parental attachment scale. And what I have here, it says Cronbach's alpha 0.708. So are we good? Is this a good scale? Somebody tell me. We good? Is in the range of 0.6 to 0.9 something? Yeah, it's good. So we're It's in the good range. Remember, the Cronbach alpha, usually they want it somewhere between 0.6 and 0.9 something. If you're up at 0.99, that suggests that you've got items in there that are basically measuring the exact same thing. So you've got some redundancy going on. Usually Cronbach's alpha is pretty tightly bound when you have a bunch of positive correlations between 0.6 and 0.9 or so, because it's a correlation of positive correlations. So it's always going to be high. So we can then say, okay, well, this is statistical evidence to create a parental attachment scale. And so then we can go ahead and say, all right, well, what I'm going to do is create my scale. I'm going to go and say transform, and I'm going to say compute, and I'm going to hit reset here, and I'm going to call this parental attachment. Okay, and I'm going to make this equal to, let's get in our reverse coded item. We're going to say it's this plus, where are our other two items? H1, let me display variable names, sorry, and sort alphabetically. H1, WP 9 and 10. H1, WP, there's 10, and then we're going to add to that 9. Okay. And we're going to go ahead and put parentheses around this. And what we're going to do is we're going to take the average. So by putting parentheses around this, we're going to divide this by 3, because there are 3 items. That's a way that you take an average across 3 items, the sum of those items divided by the number of items. Okay, so what I did is I hit backslash, and that is divided by 3. The same thing is going to work. The backslash also works for division when this is the Google search bar. Okay, so you're taking, this is one way just to compute the average, if you're computing an average for parental attachment. We could have just summed the items. You could have. Another way, though, of making a scale is just taking the average across the number of items. This is why, though, when summing or taking averages, all items have to have the same number of levels to them, because you don't want to have one item to have any undue or outsized influence over the scale. Because if one item is measured from 1 to 10 and all the rest of the items are measured from 1 to 3, but they're all supposed to be measuring the same thing, the item that's measuring from 1 to 10 will have an outsized influence over the overall distribution of the scale. And so that's why you want to have them all measured the same way, at least the same number of levels to them. The wording, exact wording could be different, but measured the same way in the response set. So you go ahead and hit OK here, and you're creating that scale, which is equivalent to the sum of that divided by 3. Okay, and so let's go ahead and run our frequencies on this item, frequencies. Let's put these back, put this back, and it should be the last, sort by file order, and it'll be the last one on there. Okay, and statistics, yeah, we can request all of these statistics make sense for this item because it's a approximately continuous scale that is measuring parental attachment. Okay, and here is our parental attachment scale that it ranges from 1 to 5. Okay, and it's the average is a 4.59. So it is a left skewed item in the sense that most people are scoring pretty high on this, how closely attached they feel to their mother. The most common response is for this is a 5, and so most people are putting 5s on all of the items. And here's the standard deviation, 0.55622. And so this is what it looks like. There are 388 people that are missing from this for whatever reason, did not report on their attachment to their mom. But it's still a relatively small proportion. We don't have to worry too terribly much about it, at least for our purposes here. All right. So next thing we could do is wonder, okay, well, how then is parental attachment correlated with delinquency? Because these two items, I mean, these are clearly separate domains. So these two things, I would hypothesize, are negatively correlated. We would expect that the more attached someone is to their mother, generally speaking, the less delinquent they are. But also, let's take a look at, might as well, the violence index as an alternative possible correlate of this. It also should be negatively correlated. So in order to do that, we can go up to where it says analyze and go into where it says correlate and back to bivariate correlation. Okay, and let's go ahead and reset all of this stuff, and let's go ahead and go down to the bottom, and let's get our parental attachment item in there. Let's get our violence index in there. Let's get delinquency in there. Okay, so again, these are all bivariate correlations, but we're looking at 3 variables in the matrix now. All right, and go ahead and hit OK. Okay, right. Okay, so here is parental attachment and its correlation with violence, the violence index. It is a negative 0.076. It is a weak correlation. It is a negative correlation, but it is a statistically significant correlation nonetheless. Remember, correlations can range from -1 to +1. If they're on the negative side, that means that as the values in one variable goes up, the other goes down. So generally speaking, those respondents that feel firmly attached to their parents are slightly less likely to report violence than those who do not feel firmly attached to their parents. And so that's kind of a non-jargony way, I suppose, to interpret the parental attachment and violence index correlation. For delinquency, the correlation is a little bit stronger. We have a negative 1.96. And so what that indicates is, like violence, it tends to be lower among participants in the survey who have relatively high scores on the parental attachment scale. So high on parental attachment scale, you tend to be a little bit lower on violence, even a little bit lower even than the average on delinquency. And again, delinquency is also statistically significant. And again, below this diagonal of ones, you see the same information just repeating itself. Okay, and so and again, the correlation, we did this already, the correlation between violence and delinquency is quite strong and positive, 0.562 as we would expect, but there is, while they are smaller, there is nevertheless a statistically significant relationship between parental attachment and violence and parental attachment and delinquency. Both are negative, meaning when parental attachment is very strong, the risk for violence and the risk for delinquency are both relatively low compared to the average kid in the population, is what we would say based on the inference that we can draw from this correlation matrix, because it's supposed to be an estimate of what's really going on in the population. Which is something we'll get into a lot more when we talk about regression. Okay, so that is what we are aiming for when we are looking at correlations. We're looking at the strength, we're looking at the direction, we're looking at the significance of the relationship. We want to assess all 3 of those things. We want to be able to state the relationship in kind of a non-jargony way that doesn't use the words like negative or positive or significant. You want to say all that stuff, but you want to also be able to state it in a non-jargony way, like as they say, in layman's terms. This is also correlation matrices are also a way to assess the reliability of a scale. And so part of your task here in your homework is to create a scale or index and to assess reliability. And so you want to look at the correlations between items to see whether or not they are going to be good candidates to put into a scale. And so if we take a look at the homework assignment, I bring this up. Oops, that's not what I wanted to bring up. Let's see. There's one more exercise on here that for religiosity we didn't get to, but here is the assignment that you want to create your own scale using at least 4 items. Items should be related by a common theme, like we did today. I just laid out some items that seem to probably work well for a scale because they're all measured in the same way, all measuring the same thing. There's a bunch of items on physical health. After all, the survey is called Ab Health. There's a bunch of items on mental health. There's items on school grades. There's items on attitudes, feelings about school, and social bonding. And this is just a few of them. You can go through that list. And what might be easier is just to go to the website if you want to look at areas, thematic areas of questions to look at. Because usually if it's around a common theme, all the items will be measured in the same way. Because they did it that way, so you could make scales out of it. That was the whole point. And so you want to take a look at that, and you want to make a scale, and you want to report and comment on the correlations for all the variables in the matrix, like we did today: the strength, the direction, and the significance. And then you will report and comment on the Cronbach alpha reliability test. And so you want to create a scale that has a Cronbach alpha at least 0.6. So to do that, you want to first make sure that all of the items in your correlation matrix are positively correlated. They all have to be. And so that's something you should check first. And once they all are, then you can go to reliability. And you want to have at least 4 items in there. It's hard to get good reliability if you have a really small number of items, unless they're very strongly correlated. To actually construct your scale after you've checked the reliability, you want to take the average of the sum of the items, and then you want to report the mean, median, mode, standard deviation, the range of the values for the scale. And then I want you to paste the correlation matrix of the scale items and descriptive statistics for the scale itself, including the frequency table, onto your assignment. So just cut and paste from there. And then I want you to try correlating your scale with the delinquency scale and the violence index, like we did in class, and just report back on what you found, if it's negative or positively correlated with it. Okay, and so as well as the other example for the religiosity scale, we can work on that in class on Thursday. But if you feel very confident that you understand really quite well what you need to do here, what the task is in creating a scale, then you don't have to attend, but I'll be here in the lab on Thursday, and then I'll also send out the Zoom invite. So that is it for today, folks. We will pick up again with this on Thursday, and that will be optional for people who'd like to just run some things by me, or that you just really need some help and guidance on how we get started with this thing. Okay, so you are free to go unless you want to stick around and ask some questions. I will be here for a little while.
One quick thing about but the assignment I just uploaded. I don't know if I uploaded it right. Every time I would copy and paste like the data, it wouldn't copy and paste. It kept showing like an error. So if I uploaded the assignment 2 wrong and it's not really easy to understand, on Thursday, if you could show how to copy and paste it, I'll be on Zoom on Thursday. So you could show it, because I tried copying and pasting the image and then screenshotting it and stuff. It just wouldn't work. So
okay, yeah, if you cut and paste special, if you cut and paste as an image, then you can manipulate it so you can shrink it, so you can stretch it out. I can show you, but yeah,
because I tried to do it and I couldn't figure it out.
Okay, well, yeah, no big deal. Just I'll take a look at it, and then you can show me Thursday, or I can try to show you. But yeah, usually cut paste special is the way to get around those problems.
Okay.
All
right, thank you.
You're welcome. All right, let me end this thing, and